Okay, so welcome to today's class. You are all very welcome. Uh, so in today's class, we'll be solving questions under binomial expansion. So our first question of today is saying that find the value of the following. Okay, so we have A, which is 8 combination 3. Then we have B, which is 7 combination 1. And we have C, which is 9 combination 3 plus 9 combination what? 4. Okay, so now when we are talking about binomial expansion, we're just talking about ways in which we can expand. For example, if you have two numbers, let me say, for example, you have A and B, then it has been raised to a power which is very high, for example 10. Okay, so because you have to multiply to say A plus B, again you say A plus B, again A plus B up to 10 times. And like you doing all these things which might be very complicated and you might end up getting a wrong answer, we use binomial expansion to do what? To solve those questions. Okay, so now in binomial expansion there is what we call combination and there's what we call factorial. Okay, so this question is on combination. They want us to know how to solve when we have been given a combination question. Okay, so you can just be confirming with me by unmuting yourself. Have you ever seen this on your calculator, NCR? Have you ever seen this on your calculator? Are you there? Okay, so the NCR, what it just implies, it tells us that it is N combination R. Okay, which can be written as N R, like this. So now, if you look at the way this has been written, okay, the way this has been written, it is the same, okay? N combination R. This means that this is also the same as what? 8 combination 3. So on your calculator, if you were just to be given this question, if you are using a calculator, you would have just said 8. Then when you place that key, which is NCR, it will write a C. Okay? Then you write the 3. Then it will give you an answer. Okay? If you do it directly on your calculator, okay, it will give you an answer. So now, instead of you, because it's going to give you an answer, because here we are not using calculators. In this mathematics we are solving, we are not using calculators. Unless you learn statistics, that's when you're going to start what? That's when you're going to start using calculators. But for all these questions, you don't use calculators. So, because you don't have a calculator, we apply a principle which is a combination principle, which is written like this. If you have N combination R, it is the same as writing it as N factorial. For you to solve it, you get the one on top, you say N factorial over N minus R. So you get the one on top, you subtract with the one at the bottom. Then you get N minus R, then you just add the factorial. Then you say the one at the bottom, now you write it here, which is R factorial. So this is the formula which we are going to be using as we solve all these questions that we have here. So starting with A. Okay, A, they've given us to say 8 combination 3. Okay, so this is the same as writing it as 8 factorial over 8 minus 3. Factorial, then you get the one at the bottom, 3 factorial, which is the same from this formula that we had here. Okay, then you're going to say this is equivalent to, so let me write it here. So it's going to be, this is equivalent to, it's going to be 8 factorial over 8 minus 3 factorial. It's going to be 5 factorial, then times the 3 factorial. Okay, which will be equals to, when I say factorial, what it just implies, for example, when I say this is 4 factorial, what I just mean it is that it is 4 times the next number that is less than 4 by 1. It is what? It is 3. Again, you multiply by a number which is less than 1 or which is less than 3 by 1, which is what? 2. So you will be decreasing like that by 1 until you reach 0 factorial. And you need to note 0 factorial is the same as what? 1. Okay, and 1 factorial is the same as 1. These things are the things you need to do what? To note. Okay, so when you reach here, you've noted all those things. You're going to say this is the same as 8. So you start reducing. 8 times 7 times 6 times 5. So I'll end on 5 factorial. Why am I ending on 5 factorial? I'm ending on 5 factorial because at the bottom I have a 5 factorial. Okay, with this 5 factorial is multiplying, because I don't have any other 3 factorial which is similar to the one on top. I'm going to also expand this one by saying 3 times 2 times 1 times 0 factorial. Okay, so the 5 factorial and the 5 factorial are going to cancel. As a result, I'm going to remain with 8 times 7 times 6 over 3 times 2 times 1 times 0 factorial. Now, you can reduce these numbers. If you have factors that can enter into these numbers at the bottom, you can reduce the numbers on top. For example, we have a 3. 3 into 3, it is 1. 3 into 6, it is 2. Okay, then here we have a 2. We can just say 2 into 2, it's 1. 2 into the 2 which has been gotten here, it's also 1. As a result, at the bottom, you're going to have a 1 times 1 times 1 times 1 times 0 factorial, the same as what? As 1. So it will be 1 everything here. Then, so you're going to have 1 at the bottom. Then on top, you're going to have 8 times a 7, which is just 56. As a result, 1 into 56, it will just give you a 56. So that is how you solve these questions. Are we together? Are we together, everyone? So you can just confirm by unmuting yourself, and because I'm not able to see what you're doing in the like when you give a thumbs up, I'm not able to see. Is it clear?
Yes, it's clear.
All right. Okay. So then you are done with the first one. Then you go to the second one, which is B. Okay. When you go to B, which is just 7 combination 1. Okay. So 7 combination 1 is just the same as writing it as 7 factorial, what we've discussed, over 7 minus 1 factorial. Then you write the 1 factorial, which is equivalent to 7 factorial over 7 minus 1. It will be a 6 factorial times the 1 factorial. Okay, then this is going to be equals to 7. It will be 7 times 6 factorial. I'll end on 6 factorial because I have a 6 factorial at the bottom, so meaning that they can divide. Okay, I'll also write 6 factorial here times 1 factorial. Okay, so I'm going to cancel the 6 factorial out of 1. Remember that 1 factorial is the same as what? As 1. As a result, I'm going to have a 1 at the bottom on top I'm going to have a 7 times 1, it will be a 7. Okay, as a result the final answer will be a 7. Okay, and you're done with B. Now when you go to C, for C you have been given 9 combination 3 plus 9 combination 4. Okay, so this is just addition. So what you do is that you expand this one using the formula separately, then you add the both. Okay, so you can just do it together by saying this is equals to 9 factorial over 9 minus 3 factorial 3 factorial. Okay, plus, then here you're going to say this is 9 factorial over 9 minus 4 factorial 4 factorial. Okay, then this will be equals to 9 factorial over, so it's going to be 9 factorial on top over 9 minus 3, it will be a 6 factorial times 3 factorial, plus this side is going to be 9 factorial over 5 factorial 4 factorial. Okay, so which is just the same as saying, okay, let me write it like this: 9 factorial over 5 factorial times the 4 factorial, like this. So when you reach this point, you're going to say this is equivalent to 9 factorial over so let me reduce this. I'm going to say 9 times 8 times 7 times 6 factorial. That's where I'm going to end, because I have a 6 factorial at the bottom. Then I'll say 6 factorial times 3 times 2 times 1 times 0 factorial. Okay, then plus, I'm going to have here this side, I'm going to have a 9 times 8 times 7 times 6 times 5 factorial over 5 factorial times 4 times 3 times 2 times 1 times 0 factorial. Okay, so you're going to cancel the 6 factorial. 6 factorial will go, the 5 factorial will go, the 5 factorial will go, and then now you have this is the same as 1. So you have 3 into 3, it is 1. 3 into 9, it is 3. 2 into 2, it is 1. 2 into 8, it is a 4. Okay, then everything at the bottom this side, it has become a 1. So we have a 1 already this side. At the bottom there is a 1. Then on top we have a 3 times 4, that is a 12. 12 times 7, that is going to give us so 12 times 7, this is a 4. Okay, carry 1, then it will be 84. Okay, so 12 times 7, that will be 84. So this side it will give us 84. Okay, 84. Then plus this side it's going to give us, so this side 4 into 4, it is 1. 4 into 8, it will be a 2. Okay, then 3 into 3, it is 1. 3 into 9, it will be a 3. Then we have a 2 here. 2 into 2, it is 1. 2 into 6, that will give us a 3. Then I'll say at the bottom here I have a 1. Then on top I have 3 times 2, that is a 6, times 7, that is, so 6 times 7, that is 42. Okay, so 42 times 3, so I have a 42 times the 3, it will give me a 6. Okay, then this is going to give me 126. So as a result, I'm going to have 126 this side. Okay, So therefore, I'll have 1 into 84, it will be 84 plus 126. As a result, I'll get my final answer to be a 200. Are we together?
Yes.
Alright, so that is how you solve combination questions. So all those questions you can have on combination, this is how you solve them. Okay, now let us look at another question. Let us look at the second question of today. Okay, so our second question for today, we are being asked, okay, for any positive integer n, show that this is equals to this. Okay, so they want us to show how so in this one, that's what you do. So we have a, which is n combination 2 is supposed to be equals to n squared minus n over 2, and we have b, where we have n combination 3 is supposed to be equals to n n open brackets n squared minus 3n plus 2, okay, over 6. That is what it's supposed to what to give us. So now when you're proving, regardless whether you're proving from sets or anywhere, you need to understand that you need to separate these, because on an equation you have the left hand side and you also have the right hand side. Okay, so this is the left hand side and this is the right hand side. Okay, so starting with a, it's going to be n combination 2, okay, it's supposed to be equals to n squared minus n over 2. Okay, so we've identified that this side is the right hand side, this side is the left hand side, this side is the right hand side. So you pick a side which you are going to get. So the side which you get, it is a more complicated side, and the side that is easier for you to apply the principles and solve. Okay, so now on this question, the side that is more complicated and it is easy for you to apply the principles, it is the left hand side. Okay, it is the left hand side. So what you're going to do is that you're going to say, taking the left hand side. Okay, so let me just use a different page to say, so I have a, which is n combination 2 must be equivalent to n squared minus n, okay, over 2. Okay, that is what I'm supposed to get. So I've identified this is the left hand side, this is the right hand side. So I'm saying taking the left hand side. So when I take the left hand side, I'm going to say that I have n combination 2. Okay, so n combination 2 is equals to n factorial, remember the formula I gave you, n factorial over n minus 2 factorial 2 factorial. That is what you're going to get. Okay, so now here you can just say this is equivalent to the one on top, you have the n factorial. Okay, so let me to rewrite this. Let me just explain it here. So here you have n factorial. Okay, then here you have n minus 2 factorial. So now what you're going to do is that here, since you have n factorial, if I was to ask which one is big between the n factorial and n minus 2 factorial,
I think n factorial is big.
Yes, so n factorial is big. So what you're going to do here is that when I have an n factorial, what I just mean is that I have n, the next one will be multiplying with a number that is less than n by 1, which is just n minus 1. Okay, that's the number it's going to multiply with. Again, this one is going to multiply again with another number which is less than this number by 1, which is just n minus 2. So this can be continuous as long as you have a number. Okay, the n, you don't know what n is. Okay, so it can be continuous, it can be n minus 3, n minus 4, n minus 5, just like that. So n factorial is the same as this. So I'm going to end on n minus 2 factorial because at the bottom I have n minus 2 factorial. So it's going to be equals to n minus 1, n minus 2 factorial over, because this is the same as the n factorial. Okay, so because it is the same, I'll do that. Then I'll say n minus 2 factorial times the 2 factorial. Okay, now here I have n minus 2 factorial. So this and this can cancel. Okay, as a result, I am going to have n minus 1 over 2 factorial. So this is equals to, you can multiply now. The n times n, it will give you n squared. N times negative 1, it will give you negative n over 2 factorial is the same as 2 times 1 times 0 factorial, which is just the same as saying n to the power 2 minus n over 2 times 1 times 0 factorial. It is just the same as what? As 2. And we are seeing that this is equals to the right hand side. Are we together? Wonderful. So that is how you prove such kind of questions. So again, there's B now, which is n combination 3 must be equivalent to this. So we'll do the same process. Okay, so what is being said is that, so for B, n combination 3 must be equivalent to n squared minus 3n plus 2 over 6. Okay, that is what we're supposed to get. So even here, I'll pick the most complicated side, and that is easier for me to apply the principles. Okay, so I have my left hand side and I have my right hand side. So I'll say, taking the left hand side, okay, so taking the left hand side, which is just n combination 3, okay, this is equal to, okay, this taking the left hand side is the same as writing it as n factorial, okay, over n minus 3 factorial 3 factorial. Okay, then now the same thing that we did, since here I have an n minus 3 factorial, and I know that this one is bigger than this one, so I can expand this because this one is going to contain a component that includes this. So I'll say that n factorial is the same as having n minus 1, n minus 2, n minus 3 factorial. Okay, so I'll end on n minus 3 factorial because that is what I have also at the bottom. It is equivalent to, so I'll say this is equal to, I'll write what I've gotten there, n minus 1, n minus 2, n minus 3 factorial. over n minus 3 factorial 3 factorial. So I can cancel the n minus 3, I'll cancel. As a result, I am going to get n minus 1, n minus 2 over 3 factorial, which is just the same as saying n times n, it will be, or let me just expand first because they want me to have an n. So the n will remain, then let me just multiply what is here. So it will be n, then n times n, it will be n squared. N times negative 2, it will be minus 2n. Negative 1 times n, it will be negative n. Negative 1 times negative 2, it will be plus 2. Okay, over 3 factorial is 3 times 2 times 1 times 0 factorial. Then this will be equivalent to n squared minus 3n plus 2, okay, over 3 times 2, it is 6, times 1, it is 6, times 0 factorial, it is a 6. Okay, as a result, you are seeing that this is equivalent to the right hand side, hence shown. Okay, so you're going to write hence shown, then even you can just do the same thing. Okay, so that is how you prove this question. Are we together?
I have a question.
Yes.
So where is n factorial? Does it mean that when you have n plus 1, it's bigger than n factorial?
Yes. N plus 1 is bigger than n factorial.
Okay, thank you.
Okay. So we have another question. So that's actually what you are just asking. I'm sure you're going to see it here. Okay. So question 3, it's asking us to say that let n and r be positive integers. Okay. So these are positive integers such that n is greater than r. Okay. The one at the bottom is not supposed to be great. It's not supposed to be bigger than n because it will be very impossible for you to solve it. So the one at the bottom must be less than or what? Or equal. Okay? So n must be greater or equal to r. Prove that n combination r plus n r minus 1 is supposed to give you n plus 1 or combination r. Okay. So now, when you're solving this question, what you're going to do is that so you have your question, which is 3. We have n combination r plus n r minus 1. It's supposed to give you n plus 1 combination r. Okay, so here again you take the most complicated side. So you have the left hand side and you have the right hand side. Okay, so you're going to pick the most complicated side, and in this case the most complicated side, which is easier for us to solve again, it is this side. Okay, so I'll say taking the left hand side, I have n r plus n r minus 1. That's what I've gotten. Okay, I must find my way to me getting the right hand side. Okay, then when I do that, then I have proven that this is equals to that. So now, what you do here like what we did on the first question, when you have such kind of combinations, what you do, you're going to say that you start the first part, which is going to be n factorial over n minus r factorial. Okay, then you're going to get the r, then you're going to say r factorial. Then now you say plus, this side you say n factorial over, this is going to be n minus r minus 1. Okay, that's what you're going to do. Then you write factorial. So I've written this in brackets because I don't want the signs to be affected. Okay, because this is just one number. Okay, so I'll say n minus r minus 1 in brackets, factorial outside like that. Then now I'm going to get what's at the bottom, which is just r minus 1 factorial. Okay, I'll have that. So simplifying it further, I'm going to have n factorial over n minus r factorial r factorial. Then it's going to be plus n factorial over n minus r plus 1. Okay, the negative and the negative, then I'm going to have a factorial like that. Okay, then I'm going to have r minus 1 factorial. So now when I reach this part, my next goal, it is to find the common denominator, because we apply the same principles we use in fractions. We are supposed to find the common denominator in this case. So when you're finding the common denominator, you look on two components, because when you're dealing with binomial, you deal with n and r. Okay, so because you're dealing with n and r, you look at the component of n and of r. The first one, it is n minus r. You've seen that this one is n minus r, right? And then this side there is also n minus r, but it has a plus 1. Okay, so you've seen that these two are similar, just that there is one which is bigger than the other. Are we all able to see that?
Yes.
Okay, then again, if you look at this one and this one, they are similar, just that the other one is what? Is bigger than the other. Okay, so now we find the common denominator. So our common denominators are those ones which are big. Okay, we just put them together. We get, for example, between n minus r factorial and n minus r plus 1 factorial, which one is big, if I was to ask?
Kindly repeat the question.
So between the two, between n minus r factorial and n minus r plus 1 factorial, which one is big between these two, the ones which are similar?
It's the one that has plus 1.
Yeah, so it's going to be n minus r plus 1 factorial. Okay, then now between these two, which one is big?
R is big.
Yeah, so r factorial. So this will be your common denominator. Okay. So that will be your common denominator. Then now, what you're going to do now is that you start doing, like for example, when you are dividing in, like what you do when you're dividing with fractions. Okay, you say this side is entering into this, right? Then what are you getting? So when you divide n minus r factorial, r factorial into n minus r plus 1 factorial r factorial, what are you getting? Okay, let me explain. So when you divide this one and this one, you've seen that the r factorial doesn't have anything like like they are the same, right? So these two are going to cancel if you divide them. Okay, these two are going to cancel, but the issue which is there, it is between these two. Okay, that's where the issue is. Okay, so because the issue is between these two, I'll do this. Which one am I dividing it into? I'm dividing n minus r plus 1 factorial with n minus r. Okay, factorial. So the one on top is big. It is, this one I can write it as n minus r plus 1. Then the next one will be n, because I'll subtract by 1, n minus r factorial over n minus r factorial, meaning that this one and this one are going to what? To cancel, meaning that when I divide this one into this one, what am I getting?
N minus r plus 1.
Yeah, so you're getting n minus r plus 1. Okay, so this which I've gotten is going to multiply with the 1 on top, because we do this into this, it gives us a component, then we multiply with what is on top, which is n factorial. Okay, then we say plus, then this into this. Okay, so you find out that this one and this one are the same, so they're going to do what? To cancel. We're going to remain with the r factorial and the r minus 1 factorial. So I'm going to have, so like what I did here is what I'm going to do again for the other part. So you become good with when you just practice more, such that you won't even be doing these things I'm doing here. You just say, so since this one and this one have cancelled, the meaning I'm remaining with r factorial dividing with the r minus 1 factorial, which will be equivalent to r, it will be equivalent to r minus 1 factorial over r minus 1 factorial. Then the r minus 1 factorial and the r minus 1 factorial are going to cancel. We're going to remain with what? R. Okay, so we are getting r. So meaning that when we divide this into this, we are getting an r, which is multiplying with the one on top, which will be rn factorial. Are we together?
Yes.
Okay. So what you're going to do now is that since here you have n minus r plus 1, n factorial, and then here you have r n factorial. So let me just remove this. If I was to remove this, so you've seen that here there is a common factor, isn't it? There's a common factor, and this common factor we can just factor it out by saying that here, so let me just write it here. So we have n minus r plus 1 multiplying with the n factorial, then we have plus r n factorial over n minus r plus 1 factorial r factorial. Okay, then this one here, we can factor out the n factorial because it is common. Are we able to see that it is common?
Yes.
So you just factor it out, n factorial. Then if you factor it out, meaning that these ones now which are going to remain, they're going to add. Okay, you're going to have, so n factorial, you're going to have n minus r plus 1. Then now this one is plus r, what will remain is plus r. Okay, that is what you're going to have on top. Then you say over n minus r plus 1 factorial r factorial. Okay, then this, you're going to get n factorial. This is going to be, so it's going to be n negative r plus r, it will be 0. So I'm going to remain with n plus 1 over n minus r plus 1 factorial r factorial. That is what I'm going to have now. Then this will be equivalent to so this one I'm going to just arrange it between in order. So this one is bigger than this one. So I'm going to have n plus 1 first, then I'll write the n factorial following over n minus r plus 1 factorial r factorial. Okay, now when you reach this part, remember that the right hand side had n plus 1 combination r. So when I have n plus 1 combination r, when I expand this, I'm going to get n plus 1 factorial over n plus 1 minus r factorial r factorial, which is just the same as writing it as n plus 1 factorial over n minus r plus 1 factorial r factorial. Are we able to see that at the bottom we have the same, right? At the bottom we have the same, right?
Yes.
So if at the bottom they are the same, now look, check the ones on top. Okay, check the ones on top. If I have n plus 1 n factorial, isn't it just the same if I was to write it like this? It's just the same, right?
Yes.
So because this is just the same, you can write this to say, okay, in this case, this will be equals to n plus 1 factorial over n minus r plus 1 factorial r factorial, which is the same, which is just equals to this. And it is equivalent to what? To the right hand side. Hence shown, or hence proven.
So does it mean we are going to ignore the n minus r plus 1 factor?
Which one?
On top we have n plus 1,
Okay.
n plus 1 factor, then over n minus r plus 1 factor, r factor. Now, where has the other side gone?
Okay, this side, right? Okay. So
Yes.
let us come back here where I'm positioning my cursor. So you see where my cursor is. When we were expanding this one, we said that we get what is on top, which is n plus 1. We say n plus 1 factorial over, we get what is on top and subtract what is at the bottom. So that's when we get this. Then now we get what is at the bottom and write it as r factorial. So this one is also there, just that we get it only when we subtract what is on top minus what is down. Clear?
Yes.
Okay. So it's still there. Okay? It's still there, just that I've written it to be like this because when we expand this one, we are getting this. You've seen that these two they are the same. Right?
Yes.
And so because they are the same, meaning that it is just the same as having this.
All right.
Yes. Then it will be equivalent to the right hand side, then hence proven. Okay. So that is what you're just going to do. And you're done with your question 3. Okay. Okay. Now question 4. So on question 4, so I solved these questions. If you check on these are tutorial sheet questions. When you go to the website, you are going to find I solved the entire video, and I'm sure I posted this question on my YouTube channel. So I sent this. So for those who had access to watch the video, what I was doing there, the video is already there. So I'll show you one example here. Then from that example, we'll just do 2. Then the rest you can go on the website, so that you can just research more, like solve more, and just to get used to how to solve this. So now this question was very long, because what it was asking us to do, they are asking us to say, use both Pascal's triangle and the binomial formula, okay, to expand each of the following. So we're supposed to use the binomial formula and the Pascal's triangle. So now, starting with A, before I go to what what A is, what B is, let me explain first on the Pascal's triangle and the binomial formula. Okay, then we'll do one example. So when you're talking about the Pascal's triangle, so Pascal's triangle. So the Pascal's triangle, it was brought so that it can help in solving questions, binomial questions. By binomial, I mean when you have something like this, you're expanding a component which is like this. So since there are 2, that's why it's called binomial. Okay, so that's why it's called binomial expansion. So in Pascal's triangle, it was brought so that it can help. Okay, so in Pascal's triangle, you start with a 1. Okay, why are we starting with a 1? If I have A plus B and it has been raised to power 0, what are we going to get after everything here? A plus
1.
It's 1, right? So that's why we start from what? From 1 here. So it is 1 because in any binomial, whether as long as it has been raised to power 0, it will be 1. Okay? So even if it's a binomial A plus B but it has been raised to power 0, it will be a 1. So because to be a 1, that's what we start from. Then now, if I have A plus B raised to power 1, what am I going to get?
One.
A plus B, right? So you've seen that the coefficient are just 1, 1, right?
Yes.
So meaning that here I have 1, 1. So me on Pascal's triangle, I'm only interested in the what? In the coefficients. Okay. So in Pascal's triangle, meaning that we start from power 0 going to 1, going to 2, going to 3, going to 4, going to 5, going to 6. Okay. So in this case, what we are going to do is that it will be increasing. So when you put a 2 here, now, meaning here you are going to have a 2, 1, 1. But instead of you doing all these things which I'm telling you here, this is what they do. So the first thing they're going to write is to write a 1. Okay? Then they'll say plus 0 this side, plus 0 this side. Okay, so meaning that 0 plus 1, it will be a 1. Okay, then 1 plus 0, it will be a 1. Then again, they write again this side, plus 0 plus 0. Meaning that it will be 0 plus 1, it will be a 1. 1 plus 1, it will be a 2. 1 plus 0, it will be a 1. That's what it is usually done. Okay. So meaning that the next one, I will say plus 0. So 0 plus 1, it will be a 1. 1 plus 2, it will be a 3. 2 plus 1, it will be a 3. Then 1 plus 0, it will be a 1. Okay. So where we're going to reach on 6. Let me reach on 6. So now again, the next one, I'll say plus 0, it will be a 1. 1 plus 3, it will be a 4. 3 plus 3, it will be a 6. 3 plus 1, it will be a 4. 1 plus 0, it will be a 1. Again, you continue. Plus 0, it will be a 1. 5, 10, 10, 5, 1. Again, you're going to have plus 0, it will be a 1, 6, 15, 20, 15, 6, 1. Have you gotten how they come up with a Pascal's triangle?
Yes.
Yes. So you can create it on your own, okay, depending on how many how much the power, how big the power is. You can continue like that. You can be getting bigger numbers. Okay. So now these powers or these numbers like 1, 2, or these ones, these numbers which are here, they are representing coefficients. Okay, or let me just say those numbers that you get from what? The numbers that you get from combination, that is what this is representing. Okay, so now let me give an example of, before I solve the question, let me give an example when you're using when you're expanding using binomial or using Pascal's triangle. Okay, so they tell you to use Pascal's triangle and they've given you to say expand a plus b squared. Okay, so we know this one, we can just say, okay, this one we can just say a plus b is equals to a is multiplying with everything that is here, and the b is multiplying with everything that is here, and we're going to get a squared plus ab plus ab plus b squared, and then we're going to get a squared plus 2ab plus b squared, isn't it? Yes. So this one is you multiplying normally. Okay. Now, when you're using the Pascal's triangle, what do? You have been given, so let me use a different page. So you have a plus b to the power 2. So what you do is that you go to the power. So this one is power 0. Like I was saying, power 0. This one is power 1. This one is power 2. Okay, so we go to the one it has been raised to. It's raised to power what? Power 2. So now when we go to the raised to one is raised to power 2, we're going to get these numbers 1, 2, 1. We'll pick them. Then after picking them, we're going to come here and just say 1, 2, 1. Okay, so after doing that, or let me just say we are picking 1 2 1, right? So I'll start with the first one, which is 1. So when I get the 1, I'll say A. Okay, I'll get the first number, which is of the first component, which is A. I'll raise it to power 2. Okay, then the next component, I'm also going to collect it by saying dot product of B and raise it to power 0. Okay, the second one I'll raise it to power 0. Then I'll say plus. Then I'm going to get the next one, which is what? The next number, which is a 2. Then I'm going to get the first component, which is A. Then it's going to reduce by 1. So it's going to be raised to power 1. Then dot product of the next component, which is what? Which is B. Okay? Then I'll raise it to, this one is going to increase by what? By 1. Then I'll say plus. Okay? When I say plus, I'll get the other component, which is what? 1. Then I'll get the first component, which is what? A. And I'll raise it to power. This one again is going to reduce by what? By 1. It's going to be power 0. Okay? Dot product of B. This one again is going to increase by what? By 1. It's going to be 2. Therefore, you're going to have 1. A to the power 2, it is A to the power 2. Then B to the power 0 is the same as what? Is the same as 1. Then plus, this one you're going to have a 2. Then A to the power 1 is what? Is A. B to the power 1, it is B. Plus 1. A to the power 0 is 1. B to the power 2, it is B squared. Okay. Then you're going to say 1 times 1 times A squared times 1 is going to give you A squared. Then plus 2 times A times B is going to give you plus 2AB. Then plus 1 times B squared is going to give you B squared. You've seen that this is the same as we got when we multiplied direct. Are we able to see that?
Yes.
So it's just the same process, okay? Just that it's a method which is being used, okay? It's just a method. So we're going to use Pascal's triangle. So this is on Pascal's triangle. Now, when you go to the binomial formula, because they said we're supposed to also use the binomial formula. Okay, so using the binomial formula, for example, when you have A plus B to the power n, okay, when you're using the binomial formula, you're going to say this is equivalent to, you get the n, the power, you say n combination 0, you start from 0, okay, you say n combination 0, it will be n combination 0 is n combination 0, right? Then you say you get the first component, then you say n minus 0, okay, then you say dot product of the second component, which is B to the power 0. You've seen this?
Yes.
So that's on the binomial formula. Then you're going to say plus, the next one is going to be n1, okay, you get the first component, you say n minus 1, dot product of B to the power 1, okay, then you say plus n combination 2, okay, then you get the first component, then you say n minus 2, dot product of B to the power 2, then you say plus dot 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 until you reach a point where your n is equal to your n, okay, so that you can have A to the power n minus n dot product and your B is raised to power n. Therefore, this is what you use when you're doing what? Using the binomial formula. Okay, are we together?
Yes, we're together.
All right. So now we have a question here. We're going to solve one because of time. So we have a question which is 2 plus 1 over x to the power 6. Okay, so we'll use Pascal's triangle and we'll use binomial formula so that you can see how to solve this question. Then for more clarification, go to the website or to the app. Just go to math 1100 1120 and search for it, and go to the component of tutorial sheets, and then you're going to find these videos. Okay, so when you reach this question, which is A, so I'll say A, which is 2 plus 1 over x raised to power 6. Okay, so now let us start with Pascal's triangle. So when you start with Pascal's triangle, you go back here. So Pascal's triangle, it has been raised to power 6, right? So which one are we getting? Which coefficients are we getting? So this one is power
1, 6, 5, 20, 15, 6, 1.
Yes, we get this component here. So we are going to get so it's 1, 6, 15, 20, 15, 6, 1. Okay, so that's a set of values we're going to get. This one here, 1, 6. Okay, so now starting with the first one, I'll say 1. Okay, the 1 which is there. So I'll get the 1, and I'll get the first component, which is what? 2. I'll raise it to power 6. Then the next one, I'll raise it 1 over x to the power 0. Okay, then I'll say plus, I'll get the 6. And I'll get the first component, which is 2, and raise it to power 5, because it will be subtracting by 1. Okay, then it will multiply with the 1 over x. I'll raise it to power 1. Okay, this one is increasing by 1. Then I'll say plus the 15. Then I'll say the first component is 2 to the power 4. Then the other component is 1 over x, raise it to power 2. Plus the 20 times the 2, the first component, to the power 3. And then the second component, 1 over x, raise it to power 3. Plus the other component is a 15. Okay, the 15, another number is 15. 2 to the power 2, 1 over x to the power 4. Then I'll say plus the next number is a 6. Then I'll get the first 2, raise it to power, I'll raise it to power 1. Then the 1 over x will be raised to power 5. Then plus the 1 again, and then the 2 to the power 0, then 1 over x to the power 6. Okay, so I just start reducing. So this part, I'll have 1 times 2 to the power 6, that is a 64, times 1 over x raised to the power 0 is a 1. Okay, so I'm going to have 1 multiplying with a 64, multiplying with a 1. Okay, plus this is going to be 6. 2 to the power 5, that's a 32. 1 over x to the power 1 is going to be 1 over x. Okay, plus the 15. And then 2 to the power 4, that will be a 16. 1 over x to the power 2, that will be 1 over x squared. Okay, then plus the 20. 2 to the power 3, that will be 8. 1 over x to the power 3, that will be 1 over x to the power 3. Okay, then plus 15. 2 to the power 2, that will be a 4. 1 over x to the power 4, it will be 1 over x to the power 4. Okay, plus this one will be a 6. 2 to the power 1, that would be a 2. 1 over x to the power 5, that would be 1 over x to the power 5. Okay, then plus 1 over x to the power 6. So this one which you've gotten here, you can just say, okay, 1 times 64 times 1, that is a 64, plus 6 times 32, so 32 times 6, so 32 times 6, that would be a 2, 1, 3 times 6, so 192. So it's going to be 192 times 1 over x, going to be 192 over x. Then this one is going to be 15 times 16, that is so 15 times 16. This is going to give you a 0, 3, and then it's going to give you a 90, 0, then here to be 1, 5, 1. As a result, it will give you a 0, 4, 2. So it's going to be a 240. So it's going to be plus 240 over x squared. Then plus 20 times 8, that would be a 160. Okay, so that would be a 160 times the 1 over x to the power 3 is going to be 160 over x to the power 3. Then plus 15 times 4, that's a 60 times this, going to give you a 60 over x to the power 4. Then plus 6 times 2, that's a 12 times this, going to give you a 12 over x to the power 5. Then plus 1 times 1 times this, going to give you 1 over x to the power 6. That's what you get when you use the Pascal's triangle. Are we together?
Yes.
Okay. So this is using the Pascal's triangle. Okay, now let us use the same one using the binomial formula. So we have 2 plus 1 over x to the power 6. So using the binomial formula, you're going to say, okay, here you have the 2 plus 1 over x to the power 6. So you're going to state by saying you get the 6. The first one, you say 6 combination 0. Okay, then you get the first component, which is 2 to the power 6 minus 0. Okay, which is here. Then you say dot product of 1 over x to the power 0. Then you say plus, you get the next one, which is 6 combination 1. Okay, then you get the first component 2 to the power 6 minus 1. Then dot product of the second component, which is 1 over x to the power 1, plus 6 combination 2, and you're going to get the first component raised to the power 6 minus 2, dot product of 1 over x raised to power 2. Okay, then plus 6 combination 3, then you get the first component 6 minus 3, dot product of 1 over x and raised to power 3. Okay, then plus 6 combination 4, you get the first component, then you say 6 minus 4, dot product of 1 over x raised to power 4, then plus 6 combination 5, and then it's going to give you 2 to the power 6 minus 5, and then this is going to be dot product 1 over x raised to power 5, then plus 6 combination 6, and when they are equal, you stop from there. 2 to the power 6 minus 6, dot product of 1 over x and raised to power 6. Okay, so when you reach this point, 6 combination 0 is just 1. Okay, it is just 1. Actually, whatever you're going to be getting, like from 6 combination 0, it is these numbers: 1, 6, 15, 20, 15, 6, 1. Okay, I've shown you how to expand when you have a combination, isn't it?
Yes.
So you can expand this, you can expand it, but what you're going to get after expanding are just these numbers: 1, 6, 15, 20, 15, 6, and 1. That is what you're going to get. Okay, so meaning that here I'm going to have a 1, okay, then I'm going to have a 2 to the power 6. We're going back to the same things that we had on the Pascal's triangle, which is this one is going to be 1 plus this one is going to be 6 combination 1, it is just a 6. Okay, and then it's going to be 2 to the power 5, and then this one is going to be 1 over x. Okay, then it's going to be plus 6 combination 2 is just a 15. Okay, then this one is going to be 2 to the power 4, and then it's going to be 1 over x to the power 2. Then like this. Okay, then plus that will be a 20. 6 combination 3 is just a 20. Then you're going to have a 2 to the power 3, and then 1 over x to the power 3, then plus 15 again, to the power 2, one over x to the power 4, then you say plus the 6. Okay, 6 combination 5 is 6. Then you're going to have a 2 raised to power 1. Okay, then you're going to have 1 over x to the power 5. So it's the same as just having a 2. Okay, then this side you're going to have 6 combination 0, or 6 combination 6 is just a 1 again. Then you're going to have 2 to the power 0, which is just 1. And then you're going to have 1 to the power 1 over 6 to the 1 over x to the power 6 is going to be 1 over x to the power 6, which is just that we're going to get the same answer we got here. Okay, because now if you check it properly, we have this. Okay, we have this. That's what we have now from here. Okay, are we able to see that?
Yes.
So that's what we have. So meaning that we're going to say 64 plus 192 over x. So it's going to be 64 plus 192 over x plus 240 over x squared plus 160 over x to the power 3, and then plus the 60 over x to the power 4 plus the 12 over x to the power 5 plus the 1 over x to the power 6. And that's how you solve these questions. Are we together?
Yes, we're together.
All right. So that's how you solve these questions. So you can practice the other ones, and so that you can just become good at it. So next time we'll start from here. I'm sure time has even gone. So my encouragement is to practice more, and you're going to get the hang of it. Okay.